Okay, so back to EO 166 again. We're going to talk about some bit shifting. In order for that to take place, a couple things have to come into play. So first thing I'm going to start with is one of the main routine here. Let's create just some real simple logic here. I'll grab an input. So I got to create some tags here. I better create some tags here. So I'm going to call this one about shift, bit shift, I guess. Word one. Double integer. I'll make, say, 10 of them. How about that? I'm going to need to make a control word. Let's maybe go ahead and close this out for a second real quick. I'm going to do this here. We're going to find bit shifts in that are file shift. We have the BSL and the BSR, bit shift left, bit shift right. There's some other things, the FIFO load and FIFO unload, and these are tools that you may get into eventually, but right now we're just going to keep it simple with a bit shift left and right. So there's a couple of pieces that I want to make sure you're aware of. One thing for sure is that instruction help. This is a huge piece for these more complicated instructions, excuse me. This is going to allow you all the little details. It shows you examples. I mentioned this many times before. This is when it really starts coming into play, is when we start getting into these more complicated instructions. Now remember, even when you're taking the exam, that this is available, so you can fall back on anything that's available in the software. You should have access to. So the first piece of this is asking for is array. And as you can see, that first tag I created was for bit shift word. That is going to be our array. Remember, an array is just a series of files. So here, this word has got 32 bits to it. That is the array of the bit shift word. So that is array 0. And then if you look at it again, this would be array 1. And then if you look at the whole picture, all the bit shift words be a total of 10 words of the array. So it's all in perspective. So we're looking at, go back to the main program here. So first thing is the array. I'm going to grab that bit shift word that I put in there. I'm going to just grab one word of it. I don't need multiple words. I'm just going to grab one word. Next piece is asking for is control. So you come in here and you'll see that it doesn't have a control word. So what does that mean for us? That means we got to create a control word. So in creating a control word, we come over to tags again, new tag. We come in here, we type in, I'm just going to call it control. We got to know it's a control data type though. So we got to come here for data type and type in control. I'm going to want about 10 of these just in case I decide to do multiple things here. So I'm going to throw 10 of them together. Hit OK for that. That means I'm going to have 10 words of control. I'm going to go ahead and create this. Let's go back to the tags and see what a control word looks like. The control word, as you could probably guess, you start looking at this piece here, you see there's a lot more to a control word than what we anticipate. There's the enable bit, the done bit, UL bit, ER bit, LEN bit, lots of information going on here. So let's take a look and see what we're looking at here. Much like the timers and counters, notice they do a word, what is that, 32-bit word there? Yep, 32-bit word for the length, a 32-bit word for the position. And then we got the bits, enable, the EU, what is the EU? They got all these defined here. So DN, UL, ER, LEN. So they got them all defined here. They got some more in here apparently that they didn't actually break down into, but the pieces of it we'll be interested in would be most likely probably like the enabled, the done bit, just like we are with the timers and counters. So that's that piece of it. So when you're creating your bit shifts, you got to make sure you're developing that counter piece of it. So, or the control piece of it, excuse me. So let's go here. So we got to go back here. Now we got a control word. I'm going to grab control word 0. Now it's saying source bit. Now if you look in this example again here, we're going down here, source bit. What does that mean to us? They gotta define it right here, I think. Where was that? Ladder function block. So I got into ladder construction bit. I was thinking they got right into it, but I'm not seeing it. But the source bit is the location or the information we want to bring in. So in this particular example, they show us input 1. So we're bringing input 1 in. So whatever the value of input 1 is going to be placed into that location when we do the bit shift left. So what does that mean for us? So if I wanted to say, for instance, let's say I use just some binary value. I'm going to grab some binary value. Let's see here. I didn't create a binary bit, so let's create a binary tag then. And you could use a double integer 0 or binary. You could use a, double integer, whatever you wanted to use. So it has to be a bit level. It can't be a word. And then the last piece of this is the length. What length do we want to use? I'm just going to use 16. So we're going to use basically half of a double integer, right? So I'm going to go ahead and download this information. Okay, I'm in run mode. Okay, all this business is good. So all I have to do is close this input and I'll watch this guy come on. I'll watch this take place. Now, this is where the understanding of the data tables is really going to help us. Okay, we go to the controller tags. We go to monitor tags. We know that we're adjusting the bit shift word 0. Okay. So I want to look at the whole word, so I'm going to set this up to read in binary, so I can watch this whole word take place. Now, we use bit 0 of binary, we use that one right there, if I remember right, as our input. So I'm going to set that to a 1. Now, for me, lucky for me, I've got a control box right here, so I can trigger input 0 whenever I need to. So I want to go ahead and turn that on and off. Maybe that one is not worded properly. I'll have to, let's see what input I'm turning on here. I turn him on. None of my inputs are working. Oh, well, I guess that's not going to do me any good then. I guess I'm going to have to do something else then. I'm going to go ahead and use binary 1 then. Binary 1. There we go. Accept that. Let's go back to our tags and see where we're at now. Okay. So, looking at binary 1, goes default to edit tags apparently. So if I set this to a 1, we're going to see it take the value from binary 0 and place it here. Let's see what happens here. All right, very good, it did that very thing. So now if I take this value and set that back to 0 and back to 1 again, it's going to do the same thing again. So it's taking this information here and stuffing it here, shifting these 16 bits this way. So if you can imagine, if I keep doing this, can't seem to get it right here. I'm trying to get to is 16 bits here, just to see how this all takes place. Oh, and if I decide to switch this to an off, you will see what is going to start stuffing zeros in there. See, he's putting zeros in there now. Okay, I guess I should have gone to 8 instead of 16. This is going to take forever. Okay, now we see what's happening there. It's starting to fill the whole thing with zeros. Then, if I take and put a 1 back here, it's going to start putting 1s in there again. See how that works? Pretty sweet, huh? I'm not very good at doing this toggle thing back and forth. I should come up with a better way to do it, but you get the idea. Keep popping these things in, and it keeps popping them to the right. So, forget it. I can't do it anymore. Anyways, you get the idea. We got a value, this crazy value. We keep every time I toggle this on and off, you see this information getting shoved to the left. Now, I would have guessed it would have not gone past the 16 point. Let's see what the instructions are saying here. What happens there? Because it's saying it should dump this information here. Random bits load, invalid. Okay, so I'm not sure. When you set the value to 10, it's shifting more 1s and 0s in there. Maybe I screwed up and put something in there that didn't belong. Let's see what's going on there. Oh. Yeah, so it's definitely writing to that location, even though we only are, we set it up to write to 16. Let's see what happens if we set it up to 8 now. Or better yet, let's do 4 so I don't do so many. I have to press it so many stinking times. Let's go back to tags. No, it goes to edit all the time. Okay, that's why. Okay, so we're looking at, I don't need that open anymore. It's all messed up. This guy here. So let's see here, if I set this to 0, we can watch what happens here. We should see these 4 bits get updated here. So it looks like it's shifting the whole word to me. Even though we're only supposed to be shifting 8 bits. So it's or 4 bits. It's an Allen Bradley thing, I guess. So even though you're only shifting 4 bits, it's shifting the whole word. So you do need to be aware of that when you're programming this thing. So but you get the idea. Every time I close this contact, every time I toggle this bit, this guy shifts the bit. You don't see anything take place in here. So if I toggle this, Control T, this guy right here, you see you get the enable and the done bits to turn on, but you're not seeing anything take place here. You have to, in order to see what's taking place, you have to watch this piece of it, okay? And as you can imagine, if we go back into the ladder program, we switch this to go, I'll have to go offline, I'm sure it's not going to let me go here, BSR, bit shift right. So now I'm just going to shift it in the opposite direction. Let's just go 4 bits so we're not going crazy again. And download that information. So as you can see here again, I can toggle this bit again. You don't see really anything take place except for the enable and done taking place. But if we go back to the tags, go to monitor, we should be able to see, oh, look at there, we wiped that out. So now we're going to have to put a value of 1 here so we can see it take place, see what's getting dumped in where. But we should see a value of this getting dumped in the, we're shifting right, so we should be seeing, if we picked 4, it should come into this location right here. Let's see what happens. Just like we expected, it's coming right in at the 4th bit. And at that very moment, it just keeps shifting on to the right. So if I switch this back to 0, and we do the same thing again, now we'll start seeing it populated with zeros. I can't do that crap for business. Anyways, you get the idea. So that's how the bit shift left and right works. Next video I'll be doing is I'll do a little explanation on the bottle line as well to illustrate how that works. So, okay. All right, guys, I hope you get this. This gives you a pretty good understanding. The other point that I want to make while I got you here is the bit shift left and right is a very efficient way of handling this information. Can you do it other ways? Yes, for sure. I will accept if you come up with a solution that allows you to do experiment 8 where you can track those lights up and down and count them just fine. I'll accept that all day long as it's in a nice organized fashion. It'll be all good. Okay. All right, guys, you take her easy, and we'll talk to you soon. Bye.